Several studies on ClinEpiDB include extensive longitudinal information. In order to examine data over time, you will need to perform a more advanced search. In this session, we're going to be reviewing complex queries using related observations. Let's take a look at longitudinal data from a single participant in the MALI-D cohort. Here you can see data from this participant over time during the follow-up period of the MALI-D study. We can see that their anthropometric measurements generally stay within the normal range. We can also see that this participant had 4 episodes of diarrhea, which are represented by these blue bars. The thicker the bar, the longer that episode of diarrhea lasted. Finally, we can also see the detection of various pathogens over the course of the study, which are represented by these colored dots at the bottom of the plot. If you hold your cursor over the plot, you can see what pathogen was detected on that day of observation. From this plot, we can see the timing of diarrheal episodes in relation to when there was a positive microbiology lab test results. What if we want to identify a subset of study participants who tested positive for a pathogen immediately before an episode of diarrhea? To answer this on ClinEpi, we will need to use the related observation feature. So for the example I'm going to take you through, we're going to answer this question at the top of the slide. How many participants tested positive for Cryptosporidium within the 14 days before a diarrheal episode that was 5 or more days in duration? So now I'm going to start the live demo. Okay, so I started a participant level search of the MALI-D cohort. And the first thing that I want to do is just identify participants who had Cryptosporidium detected. So this is a normal search just like we went over in the earlier sessions. So I'm going to start by typing Cryptosporidium here. And I know that the cleaned analytic variables for the various microbiology test results stored in these multi-filter variables. So for bacterial in stool, virus in stool, and eukaryote in stool. And since Cryptosporidium is a eukaryote, I'm going to navigate to eukaryote in stool and then scroll through here until I find Cryptosporidium. I see Cryptosporidium by ELISA, and I'm going to click yes to select participants who had Cryptosporidium detected at any time during their 5 years of follow-up in the MALI-D study. So now that I know which participants did have Cryptosporidium detected, I want to know which of those in the subset also had the Cryptosporidium detection that happened within the 2-week window of time immediately prior to an episode of diarrhea that lasted at least 5 days. And so since I need to take into account the timing of observations of Cryptosporidium in relation to the timing of the observations of diarrhea episodes that lasted longer than 5 days, I'm going to use the related observation feature. So I'm going to click up here on related observation in the search wizard. And I'm going to click here, and it's going to allow me to enable these more advanced searching options. So the first thing to take a look at within the related observations is just what types of variables are represented here. So I'm going to just quickly scroll through here. I see some sample data. I'm also seeing observation details, anthropometry, info on the diarrheal episodes. So really this looks exactly like the variable tree that is in the observation step in the search wizard. And so what this is going to allow me to do is to select a separate set of observations and then use this sentence here and I can change the parameters in the sentence to account for the timing that I'm interested. So the timing of the observation in relation to the related observation. So when I'm doing this, the first thing that I always want to do is select what related observation I'm interested in. So to answer the question, I know that I'm interested in diarrheal episodes that lasted at least 5 days in length. And from this variable tree, I see this variable here, diarrheal episode duration in days. So I want to go ahead and click that. And I'm seeing a distribution of the number of days that each diarrheal episode lasted. So I'm interested in those that lasted for at least 5 days. So I'll click here and type in 5. And you can see that I've highlighted the episodes that lasted at least 5 days in duration. Okay, so now I know that for the observations of interest, it's the detection of cryptosporidium. And for my related observations of interest, it's the diarrheal episodes that lasted at least 5 days. So now I'm going to move back up to the top and complete this sentence here. So I can either remove or keep observations that are some length of time before or after the related observations specified here. So again, I want to remind myself that the observation is cryptosporidium, the related observation is the diarrheal duration. So for this, I'm interested in keeping observations. So keeping the detection of cryptosporidium, so anytime cryptosporidium was detected, I'm keeping it, that are occurring within 2 weeks. So I'm going to change this from 0 to 14 days. And then before the related observation, so before the participant had one of these diarrheal episodes that lasted for 5 days. And so what I can see here is that I've got 211 participants who had a cryptosporidium infection that was occurring within 2 weeks before a diarrheal episode lasting at least 5 days. So the next thing I'm going to do is I'm going to click over to view these participants. And this is going to bring up our results table. And so now we have a table that contains information on these 211 MALI-D participants who met the criteria for having cryptosporidium infection immediately prior to the episode of diarrhea lasting 5+ days. So now that we've gotten that list of participants, what if we wanted to ask, within the subset of 211 participants, how many of these participants also had a reduced length for age z-score at 2 years of age? So to answer this question, we need to employ a multi-step strategy. And the reason that we need to use a multi-step strategy instead of just adding an additional filter to our original search is that the second part of this question is asking us for identifying the reduced length for age z-score that occurs at exactly 2 years of age, not at just any time point in the study. So we need to apply a filter to account for the timing that we want to look at for this observation. And if we had used that filter to select participants at 2 years of age in the previous search, what that would have done would be to only return those participants who had the cryptosporidium detection before the diarrheal episode duration of 5+ days that occurred at 2 years. So if the participant had that cryptosporidium infection that met the criteria of interest prior to 2 years of age or after 2 years of age, they would be removed from the set of 211 participants. So I'm going to add this step here. And so this is going to once again allow us to look at different windows of interest in the first step and in the second step. So I'm going to click to add a step, and it's going to bring up this window here. And I have some options. So here I want to combine my original search, which resulted in finding 211 participants, with some new search, and then combine those two in a way that is interesting to answer my question. So the options for how to combine are to intersect, to union, or to subtract one search from the other. So since I'm interested in participants who meet both the criteria of search 1 and search 2, I'm going to go with intersect. And since I don't have any saved strategies, I'm going to combine the 211 participants from search 1 with a new search, which I'm calling search 2. So I'll click here. And what you'll see here is in this pop-up window to add a step to your search strategy, it's bringing up the exact same search wizard without any filters applied. So it's a brand new search, and we're going to perform this new search 2 as if we haven't done anything for search 1 yet. So I am interested in data from 2 years of age. So I'm going to click over to observation and give this a second to load. Okay, and I'm interested in observations that occurred at 2 years of age. And so since the MELODY study is measuring that in days, I'm going to want to convert 2 years to some number of days. And in epidemiology, often the observation is not conducted exactly on the second birthday, but it usually occurs within plus or minus some window that's acceptable for that study. So since I want to capture all of the data for that 2-year time point, even if it occurred a few days before or after the participant's second birthday, I'm going to put in a wider range here than exactly 2 years. So I'm going to type in 710 to 750. Okay, so that's giving us this little stretch of time in which I'm interested in identifying participants who had a reduced length for age z-score within this period of time. Okay, so now we have to find the length for age z-score. So here, length for age z-score, I'm going to click that variable. And so see here this distribution of length for age z-scores, and we have some that are in gray and some are in this pink color. And once again, just to remind you, the gray bars represent all of the data in the study, while the pinkish red bars represent the data from that matches our search criteria applied to date. So in this case, the pink is data from participants that was collected around 2 years of age. So I'm interested in those participants who had a reduced length for age z-score. So I'm going to put in -2 for the maximum. Okay. And so now if I scroll back up to the search wizard, what I can see is that I've found 575 participants who had a reduced length for age z-score measurement at around 2 years of age. So I'm going to click this combined 575 participants, and that will bring us to the new results table that combines the results from the search 1 with the results from search 2. So it's combining the 211 participants that had a cryptosporidium infection detected within 2 weeks prior to the episode of diarrhea that lasted at least 5 days, combining that with search 2, where we identified participants had a reduced length for age z-score at 2 years of age, And once we combine and find participants who meet both Search 1 and Search 2, we're left with 49 participants. And we can see the data from those 49 participants in this results table here. Thank you.